Difference quotients, essential for defining derivatives in calculus courses, are exactly the quotients computed to find the average rate of change for a function over a particular interval. Let's review the average rate of change. In general, the average rate of change of a function f over the closed interval from a to b is given by the quantity f of b minus f of a over the quantity b minus a. If we consider the average rate of change of the function f over the closed interval from a to x, this rate is given by the quantity f of x minus f of a divided by the quantity x minus a. Using the closed interval from x to x plus h, the average rate of change of the function f is given by the quantity f of x plus h minus f of x divided by the quantity h. Each of these algebraic expressions is known as a difference quotient. Now let's consider 5 examples of simplifying difference quotients. Note that correctly evaluating functions is going to be critical in solving these problems. For the given function f of x equal x squared plus 3x, we want to find and simplify the difference quotient f of x minus f of 5 over x minus 5. Note that we need to evaluate f of x and f of 5 and then simplify the fraction. 25 plus 15 is 40, so we can simplify the inside parentheses and then subtract. We would distribute the minus sign otherwise. Note that this trinomial in the numerator factors. X squared plus 3x minus 40 is equal to the quantity x plus 8 times the quantity x minus 5. We can then cancel the factors of x minus 5 to get x plus 8. Let's consider a second example. This time we're given g of x equal 3 over x and asked to find the difference quotient g of x minus g of a over x minus a. We will get a complex fraction to simplify in this problem. We evaluate g of x equal 3 over x and g of a equal 3 over a and substitute, resulting in the anticipated complex fraction. To simplify the complex fraction, we can multiply numerator and denominator by a times x to clear all the fractions. Distributing in the numerator does clear the fractions. We choose not to distribute in the denominator because the eventual simplification of fractions requires factoring, which is the opposite of distributing. We can factor 3 out of the numerator, replacing 3a minus 3x with 3 times the quantity a minus x. Notice now that we have opposite factors, a minus x and x minus a, on the top and bottom respectively. We can reverse a subtraction by factoring out -1. Thus, we should have factored -3 out of the numerator. Remember, when factoring polynomials with negative leading coefficients, we always want to factor out the negative. The polynomial 3a minus 3x can be viewed as a -3x plus 3a. The variable is typically x, and the letter a often represents a constant. The distinction between variables and unknown constants called parameters is a topic for another day. Finally, we can cancel the x minus a and get -3 over ax. Next, we want to find a difference quotient f of x plus h minus f of x over h, given that f of x is 3x minus 4. We will evaluate and simplify as before. Notice that f of x plus h is 3 times x plus h minus 4. Also note that we are careful with the use of parentheses. Next, we distribute, collect like terms, and cancel the h. The important aspects of this example are correct function evaluation, appropriate use of parentheses, and careful simplification. For example 4, let's alter the look of the difference quotient and use a quadratic function. Once more, function evaluation will be critical. Note that f of 3 plus h is 3 plus h quantity squared. Remember also that the technique for squaring a binomial is to FOIL or distribute. So 3 plus h quantity squared is 9 plus 6h plus h squared. The 9's add out. Now we factor h in the numerator and cancel to get h plus 6. For our final example, let's use a function with both a fraction and a quadratic. First, we evaluate the function at x plus h, and then at x. We now have a complex fraction. Before we jump in and start FOILing x plus h quantity squared, let's think about how best to proceed. We really want to simplify the complex fraction. One option is to write the numerator times the reciprocal of the denominator. This looks a bit better, but we still need to combine the fractions in the parentheses. This step requires a common denominator. The common denominator is x squared times the quantity x plus h squared. Now we need to square x plus h in the numerator and distribute the minus sign. We know that x plus h squared is x squared plus 2xh plus h squared. When we distribute the minus sign, the x squared terms add out, and now we can factor and cancel. We factor a negative 8h out of the numerator and cancel the factor of h on top and on bottom. Notice that we left the denominator in factored form throughout the problem. This is because we knew we would eventually simplify the fraction by factoring and canceling. When we are working complicated or involved problems, we need to proceed intentionally with the end result in mind and not jump into plug and chug mode without thinking.